Alright guys, go ahead and try the warm-up. Make sure you put me on pause and then resume to check your answer. 45 a to the fourth, b to the third, minus 90 a to the third, b to the first, divided by 15 a squared, b to the first. So we're dividing. The rule they want you to remember is that when you divide with same bases, you subtract the exponents. However, be careful because really you're dividing the first term of the numerator by the denominator, and then you're also going to divide the second term by the denominator as well. So you could actually separate this and do it, put them both over the 15a squared b, or you could just not separate it and do that part in your head. So we have 45 divided by 15 is 3, and a to the fourth divided by a squared, you subtract your exponents and get a squared. B to the third divided by b to the first would be b squared, minus, now do the second grouping. 90 divided by 15 is 6, and a to the third divided by a squared, subtracting your exponents, would be a to the first. I'm not going to write it, leave it as an imaginary. And then b to the first divided by b to the first is really b to the 0, and anything to the 0 power is 1. So we get 6 times a times 1 would be 6a. I cannot subtract these. This is what you have to remember for this one. I cannot subtract these because they're not like terms. So that would be my answer. All right, 8.8 is what we're going to do. If the polynomial, the title is factoring by grouping. This is the other method you guys can use. Actually, we're going to really zoom in on factoring with 4 terms, a polynomial with 4 terms, but this is going to help you down the road with trinomials. So watch carefully what we do, because this method is actually used for other types of factoring and trinomials that will make it easier than guessing and checking, which we've had to deal with. If the polynomial has more than 3 terms in it, first look to factor out a GCF. Then group the first 2 terms and the second 2 terms to form 2 binomials that can be factored. Make sure you write this down. This is kind of the strategy. I try to simplify the strategy up, and then go ahead and put me on resume so we can go on to the next screen. All right, let's look at an example. If you look at this example, it wants us to factor it. 3n to the third minus 12n squared plus 2n minus 8. Because there are 4 terms in here and none of them are like terms, factoring means we're going to group them. So we're going to group the first 2 terms together and the second 2 terms together. Make sure before you group them, the polynomial is written in standard form. In other words, the highest exponent goes to the smallest. So when you get them into groups, you're going to look at for the first group only, and you're going to ask yourself, is there a GCF? Which there is. It is 3n squared. I can take a 3n squared out of both of these terms. So factor it out. That would give me 3n squared times n would give me the first term, minus 3n squared times 4 would give me the second term. You can check it by doing distributive property in your head to make sure it comes back to the original problem. Plus, drop that down. Now look at the second group and ask yourself, can I take out a GCF? Yes, it's a 2. Take out the 2. 2 times what is the first term? It'd be n. 2 times what is the second term? Would be a 4. Notice, guys, that the binomial in the first group, after we factored out the GCF, is exactly the same as the binomial in the second group. That has to happen for this grouping method to work. This has to be the same as this. If it's not, then you may have made a mistake and not taken out the GCF, and you may have to manipulate it. Or if you did take out the GCF correctly from both, and this binomial does not end up being the same as this, then we cannot factor it by this method. Okay? So once you get it to this point, then you're going to take that common binomial, that they both have, and rewrite it down here only once. The other binomial is going to be comprised of the two GCFs. So the GCF on the first one was 3n squared, and the second one is a positive 2, so it would be plus 2. This binomial can no longer be factored. It's in factored form, fully factored, and 3n squared cannot be factored anymore either. So that would be the final answer. How would I check my answer? You would check it by doing FOIL, just like you usually do. And don't worry about the exponent and how they're different. It will work back out to this polynomial with 4 terms in it. All right, let's try another one. 4q to the 4th minus 8q to the 3rd plus 12q squared minus 24q. Why don't you guys go ahead and put me on pause and try it yourself to see if you have the technique, and if not, go ahead and put me on resume and we'll figure it out, okay? Hit pause, please. All right, I can break this into 2 groups. Now, I better be careful, because before I break it into 2 groups, I need to first think about, is there even a GCF? Because if I can take a GCF out of this first, then I actually am going to make this problem a lot easier. And there is a GCF. It is a 4. Q. So I can take out a 4, and I also can take out a Q, 1 Q from each of them. So let's go ahead and factor it out. 4Q times what gives me the first term? That would be Q to the 3rd. 4Q times what gives me the second term? That would be 2Q squared plus 4Q times what gives me the third term? 3Q, and 4Q times what gives me the fourth term would be 6. So just make sure and do a quick mental check, distributive property, and make sure that each one of these distributed in is going to get back to the 4 terms up above in that polynomial. Okay, once you get the GCF pulled out, you don't want to lose this. That answer, that GCF is still going to be a part of your answer. So I'm going to drop it down, but now I'm going to go ahead and change colors here. I want to group. So I'm going to group this one, and I'm going to group this one. And the reason why I'm grouping is because I have a polynomial with 4 terms in it, and that's one strategy in factoring one like that. So in my first group, I can take out a GCF, which is Q squared. Q squared times Q minus Q squared times 2 will get me to the second term. So quickly distribute it back and make sure that it comes back to this grouping of this binomial. Okay? Then look at the second group. There is a GCF in here. It's a 3. Now remember, see this Q minus 2? This needs to come out as Q minus 2. If it doesn't, we made a mistake somewhere, or this could possibly be not factorable. 3 times Q minus 3 times Q is 3Q, and 3 times 2 gives me 6. This Q minus 2 and this Q minus 2 are the same, so that's an indicator that we're on the right track and this is factorable. Once you get to that point, you're going to drop down the Q minus 2 that they both have in common, and you're only going to write it once in parentheses. So there's one of them. The other binomial is made up of your GCFs. So you're going to have Q squared, and that's a positive 3, not a negative 3. So you put plus 3. There's my monomial. This binomial can no longer be factored, and this is no longer factorable. When you guys go to check this, you can FOIL this first and then distribute the 4Q through, or you could distribute the 4Q through to the first one and then FOIL. Either way will work. Okay, so this is the last screen for 8.8. It says the toy shown below is made of several bars that can fold together to form a rectangular prism or unfold to form a ladder. What expressions can be represented by the dimensions of the toy when it is folded up? Use factoring. Interesting enough. Do you see this problem, guys? Is this a trinomial, or has it got 4 terms in it like the last 2 questions? This is a trinomial, so actually there's no grouping intended on this, even though that's the section we're in. This is from the last few sections, actually 2 sections ago. We have 6x cubed plus 19x to the second plus 15x. We just want to factor it. It's a trinomial, and there is a GCF. It is x. So x times 6x squared plus 19x, I'm factoring out my GCF, plus 15. Drop down your GCF, don't lose it, just drop it down. Now let's see if this is factorable. Now, notice the leading coefficient is a 6. This brings us back to the ones that are a little bit of a headache. So we have to guess. Are we going to use 1x and 2x, or 1x and 6x, or 2x and 3x? I'm going to try the 2x and the 3x. If this isn't going to work, I'm going to go back to 1x and 6x. They're both plus, so I know we need a plus plus. The factors of 15 are 1 and 15 and 3 and 5. I'm going to try the 3 and the 5. It may not be right, but we're going to try it. And then I'm going to check. So 2x times 5 is 10. And 3 times 3 is 9, and 10x plus 9x is 19x. So my guess actually worked. If it hadn't, I would try switching my 3 and my 5. And if that didn't work, we'd have to go back and try, instead of 2x and 3x, try the 6x and the 1x, or the 1x and the 6x. So this is equal to the dimensions of the toy. So think about this. We're talking about our rectangular solid here. And they wanted to know what the dimensions are. Well, the dimensions would be possibly, this would be x, that's this one. This we could call 2x plus 3, that would be this one, and 3x plus 5, which would be this one. So those would be the possible dimensions of this rectangular solid, which they call this toy that's made up of bars that form a ladder, unfold to form a ladder. Okay, and that takes care of lesson 8.8.